Well, welcome everyone to the TRI Alliance training program. I would say good morning or good afternoon, but we actually have people from across half of the world today, so that's pretty interesting. Today is a short course. Our primary presenter is Paul Oleksak. He's a technical trainer from Boral Roofing Products, and he will be talking about fastening in the high wind zones. My name is John Jensen. I'm a roofing contractor, but I also manage the training program for the Tile Roofing Industry Alliance. Lisa Jensen is monitoring today so that although we will open up the microphones at the end of the training so that we can have a dialogue, she'll be monitoring the entire time so that if a question comes up, you're able to use the feature on your GoToWebinar, your question feature, to send a question to her, and she will help get it injected into the conversation. And again, Paul Oleksak is our guest speaker today, and he is, again, a technical trainer with Boral. He has terrific experience in the tile roofing industry. He lives in Florida and has terrific experience in Florida also, so he's perfect for this. And we'll talk a little bit more about what he does for us and has done for the industry in a moment. What is the industry? The Tile Roofing Industry Alliance. We are a manufacturers association primarily, so that means you see those familiar logos and names in the center of your screen. Those are our driving producing members. And that makes us a manufacturers association, but we're an alliance in that we have an informal alliance with everyone in this relatively small segment of the overall roofing industry, where we depend on and benefit from each other's expertise, whether you're a manufacturer, a supplier, a distributor, a contractor, an inspector, a consultant, an engineer. We can share that information here and benefit everyone. And that's what the goal of our industry is to get the information out to promote the sale and proper installation of clay and concrete roof tile. There's a tremendous amount of information on our website at tileroofing.org. One way you can end up on that website is in our Find a Contractor or Find a Manufacturer, Find a Supplier search there. And the way that you get on that map, on that search, is through taking one of our manual certification courses, or you can also join TRI as a member in the category that's appropriate for you. Our training program consists of primarily manual certifications. One is the concrete and clay roof tile installation manual training, and that manual covers 49 states. It is essentially a minimum standards manual with examples of options for upgrades. It was developed between our TRIA manufacturers and the Western States Roofing Contractors Association. So we had both contractors and manufacturers involved in that development. The other manual, and that's the one more appropriate or pertinent today, is the Florida High Wind Manual certification. That manual is only applicable in Florida. The testing and the data still are relevant, but the manual and the requirements are only applicable in Florida under the Florida Building Code, and that manual was developed in cooperation with the Tile Roofing Industry Alliance manufacturers and the Florida Roofing Contractors Association. In addition to those trainings, we have trainings like today, which are short courses where they'll be less than an hour. We'll typically have only one presenter. It will dial into a subject and delve deeper into a subject where that person has particular expertise. And Paul is one that definitely has that, in addition to the schedule where you can see where we are today, April 2nd, with Paul. Next week, we've got a manual certification. We've got another TRI short course in a couple weeks with Reagan Campbell. She will talk to you about using social media in the construction industry to engage your customers. And then the Florida High Wind Manual. We've also got a YouTube channel that will give you the chance to revisit what you hear today. Paul has several videos up there on dealing with high wind. Wade Shepard, who also is from Boral, has a very in-depth presentation on the new 6th edition Florida manual. Those are all available for free to revisit on our YouTube channel. For example, me as a contractor, if I were getting used to and familiar with the new 6th edition manual and I found out I was in a 130 mile an hour wind zone, I would go to our YouTube channel and I would click on Paul's video, which is specifically for figuring and factoring in what you need to do in a 130-mile-an-hour wind zone with multiple examples, and that's all that he focuses on for that video. He's got those for 130, 140, 150, 160, 170, so you really can learn at the same time when you get the information that you actually need. So check out those resources, our website and our YouTube channel. There's some great information there. Lastly, who's here today? We're from all over the place. We've got from down in South Africa and Colombia. You can see that the bulk of our folks today are from Florida, although it looks weighted to California. That's where our manufacturers are based. We've got Eagle technical people and Wade from Boral out there, and a couple of roofing companies. I'll let Paul go into the relevance of the information he's going to present today to outside of Florida, but still the information will be super helpful for all of you. So I'll turn it over to Paul Oleksak from Boral Roofing, and he will take it over for the fastening in high wind zones.
Paul, you have control. All right, everyone, you should be seeing Paul's screen, which is titled U.S. High Wind Calculating Fastening Requirements. If you're getting a message that you're still waiting, you may need to refresh your screen or sign back in. Go ahead, Paul.
Yeah, hi everybody. Paul Oleksak, Boral Roofing. I'm a technical trainer, and I'm the one that gets most of the calls when roofers would like to know how to fasten in high winds. High wind is defined, some people define it as over 100 miles an hour, but it's definitely over 110. We use the data from the American Society of Civil Engineers, the ASCE group folks, and watch when they put out a new bulletin, and then change our fastening patterns according to their new requirements. Just recently, ASCE 7-16 came into effect, and we had quite a shuffle because it did change requirements, especially in Florida. So although we'll talk about the whole country briefly, we're going to end up looking at how Florida handled ASCE 7-16, and we'll give you 6 examples of roofs in Florida at the new, using the new design calculations in ASCE 7-16. For the rest of the country, other than Florida, including Alaska and Hawaii, we are still using the TRI concrete and clay installation guides, and they are still based on 7-10. There's a reason for that that goes into the International Building Code, but they have not made tables for ASCE 7-16. So if you're outside of Florida and you want a high wind, then you can go ahead and use this manual and use the existing 7-10 tables. They also have 705 tables in there, and on pages 77 through 98 are 20 pages for you engineers out there of really good engineering for both the ASCE 7-05 and 7-10. So it's quite chock full of how roof tile uses a uplift moment instead of a pressure, and how you calculate your fastening resistance to the requirements based on what kind of roof you're putting on. That being said, there are other high wind fastening options, and the most popular or the best known outside of the Florida code is the MiamiDade code. MiamiDade is basically a code for a given wind speed, 175 miles an hour, all right? And it uses its own installation instructions, and described in their roofing application standards, RASs. You have RAS 118, which is direct to deck, RAS 119, which is batten system, and RAS 120, which is a foam adhered system. They take the data and they have converted to ASCE 7-16 and put it in a wind table under RAS 127. They then require us tile manufacturers to put in approvals, and not only put in for approvals, but test quarterly our tile to make sure that we meet all of their standards. So it's quite specific. I know in other parts of Florida, engineers and building designers and architects are saying, hey, I don't care about the Florida code. I want you to do my house in up northern Florida. I want you to use MiamiDade product approval. All right. And that isn't equal to the Florida product approval. And I'll show you that in a minute. So it's something to look at for you people that are interested out there in seeing what the RASs look like. If you Google the Florida Building Code 2020 and you actually look for a printouts, go to the protocol section and you can view them for free, or you can pay $35 and get the whole set. So it's a nice $35 investment if you're going to you want to learn about wind design at 175 miles an hour in Miami-Dade County, Florida. One exception to the whole country, like Miami-Dade's an exception to Florida, is the TDI, the Texas Department of Insurance. They have their own little set of rules that they require in what they consider high wind in Texas. And they basically have us manufacturers test the tile, and then they do the calculations, and then they put their fastening, both the fastening requirements and the uplift moments for what a certain tile will give at a certain wind. And so it's something that if you're in Texas, and you're on the coast, you might want to look at. One of the things I found when doing this presentation is some of the tile manufacturers say, okay, besides being endorsed by the, not endorsed, besides being approved by the Texas Department of Insurance, some roof tile companies will put this disclaimer at the bottom. The roofing tiles must be installed in accordance with this product evaluation and the Florida High Wind Guide. Other manufacturers just say their roofing tiles must be installed in accordance with the TDI and their installation manual, which is either the Florida manual or that first manual I showed you. So just something to, again, if you're going to be doing more research, look up Boral, Eagles, Crowns, Ludowicis, look at our TDI approvals, and it'll give you some more information as to how we're all handling high wind and fastening. Here's the intro into the Florida code. This is actually the Florida Building Code. And if you look at the bottom, okay, it says tiles shall be applied in accordance with this chapter, chapter 9, and the manufacturer's installation instructions and recommendations of the FRSA TRI Florida High Wind Concrete and Clay Installation Manual, 6th edition, or the recommendations of RAS 118, 119, or 120. And that's the Miami-Dade code. So what I'm showing you here is in Florida, you've got to install to the 6th edition Florida High Wind Guide from the TRI and the FRSA. The FRSA is the Florida Roofers, by the way, or the Miami-Dade code. For you design professionals, the 6th edition does have 3 pages of formulas and how we figured how we came across with our tables and such. So it's good reading if you understand all that, but it's in the book on pages 18, 19, and 20. By the way, you can download the FRSA TRI 6th edition from the TRI website. Just go to installation manuals. And not only do we have the 6th edition, which became effective January 1st of this year, well, actually December 31st of last year, but we also have the 5th edition still there if you want to see, like, for instance, a building you did last year, that you would use the 5th edition for that. That would be ASCE 7-10 in Florida, and then, or you could use the 6th edition, which is ASCE 7-16, which is the 6th edition, or 6th edition, which is ASCE 7-16. All right. The difference with the ASCE 7-16 is the roof zones. In ASCE 7-10, we had 3 wind zones. In ASCE 7-16, we have 10 zones, and the fact that the gable roofs are different than the hip roofs. Okay, the hip roofs have the corners, the 4 corners of the hips are a higher. This better example. I have the high pressure zones, and the gable roofs have 4 different zones, the bottom of the gable and the top of the gable. So that's zone 3E and 3R, and the low pressure zones 1, 2E, 2R, and 2N. So just letting you know this before we go into our examples. When you're doing a job, you can either fasten to the highest pressures and do the whole roof that way, or you can do 2 fastening methods. The method for the high zones, just doing the high zones, and then the method for the low zones, doing the low zones. And there's a way to figure out the high zones with that formula at the bottom of the screen. All right, let's use the 6th edition and do some examples. It's all based on table 3. We're talking about fastening. So we did testing, taking tile and taking the 3 different types of tile. What we mean by types are profiles. A low profile, which is a flat tile, a medium profile, which is a double roll or small rolling tile, and a high profile, which is the one large hump, typically Spanish type tile. Okay, and we did uplift tests on that, and we came out with uplift repressures, and those are listed in table 3. Under foam is not listed there. Foam came in after that testing, and they have their own uplift moments. So when you calculate your resistance, what you need, you then go to the foam companies and see what resistance they offer based on patty size and patty placement. So we won't spend too much time on foam, but more and more people are using foam, especially in the higher wind calculations. All right, now the tables we have 6 tables now, 3 for hip roofs, 3 for gable roofs, and for each exposure. Exposure B, which is a well compacted area, a very close city area. Exposure C, which is normal area of housing, you know, and exposure D means you're right on the water. The 6th edition has those exposures defined in the back in the glossary, but for the 99% of our roofs, which are exposure C, that's what we're going to talk about today. Here's what we need to know to do our fastening determination. We need to know if it's a hip roof or a gable roof. We need to know the exposure we just talked about. We need to know the roof pitch. Then we need to know the wind speed. Then we need to know where our low pressure zones and our high pressure zones on that roof are. We need the mean roof height, the halfway between the eave and the top of the ridge. Then we need to know what tile we're going to use. we have to look at the tile ratio. I'll get into that in a minute. And then we're going to have to figure out how are we going to fasten it. Are we going to use nails? Are we going to use screws? Or are we going to use foam? Okay, here's an example of the tables. As you can see now, tables are 2 HC, 2 GCs. The difference is the table on the left is a hip table and the table on the right is a gable table. Okay, so again, you'll have to look at the roof to determine that. So let's look at 140 miles an hour. Here's the example we have for 140 miles an hour. And that includes the mid part of Florida. I didn't want to go too low a wind, and I didn't want to go too high. So I took the medium speed wind of 140. Well, probably some of you people out there think 140 is not medium. In Florida, it's a medium speed. But, you know, if you're living in a 90 mile an hour wind zone, that's pretty high. But let's do some examples so you can see how this flows. All right. We're going to do exposure C. We're going to do a tile ratio of 1.1. We're going to do 3 hip roofs, and we're going to go 3 gable roofs. The 3 hip roofs are going to be at each slope range, and the 3 gable roofs will also be that same slope range. Okay, there's 3 steps to fastening. Find your table. Okay, find out, you know, go is the hip table or gable table. Find your uplift moment, all right, and then find your fastening resistance in table 3. So let's start by finding your table. And if you look up top, example 1 is a hip roof, exposure C at 140 miles an hour, less than 4.5 on 12, with a tile factor of 1.407. Time to talk tile factor. The tiles that were used in the testing were a certain size, and we found that tiles will over time get bigger because there's less pieces per square. So there comes a point where you'll have to factor in the larger tiles, and I'll show you that. But at 140 miles an hour, at less than 4.5 on 12 roof slope, and let's say we have a 30-foot mean roof height, both our low pressure zone and our high pressure zone are the same. And that's kind of common in a lot of lower height roofs. So we have to we have to find a fastening system that's going to offer 25.4. So before we do that, we're going to have to look at the tile ratio, and let's look at the biggest tile out there. Now, a smaller tile would actually give you a lower uplift moment, whereas let's just show you an example of the higher one, takes that 25.4 and moves it to 27.9. All right, so in example 1, 140 mile an hour, less than 4.5 on 12 slope, tile ratio 1.1, we had to meet 27.9. We go to our table 3 and direct deck. Okay, we look at what fastening methods will meet that 29.9, and there they are all listed depending on your profile, your tile. 2 ring shank, ring shank nails will meet all 3 criteria. All right. Example 2, 140 miles an hour. We're going to go to a mid slope range, 4.5 to less than 612. A mean roof height of 30-footer less. We'll use a high tile ratio just to get an idea. We find that here we only need to meet 21.2 foot-pounds. Okay, with the tile ratio we have to meet 23.3. So we go to table 3, and sure enough, on the low profile tiles, everything works. Okay, any one of those fastening methods work. A nail by itself is not on that table, so you can't use it. You have to use something on that table, but anything on that table that you want. It's or foam, any foam that meets 23.3. So we go, keeping with the hip roofs, we go to the steep hip roofs, and now you'll see a difference, okay? Because at the 30-foot mean roof height, first thing you see is our low pressure zone is less than our high pressure zone, okay? And we factor in the tile ratio, all right? And we see the low pressure zone at 29.5 foot-pounds. And for instance, in the medium tile, we see that those fastening options will beat 29.5. When we look at the higher zone, 35.8, not everything meets 35.8. So one screw on a medium profile tile, which is 33.2, it's better than the 29, okay, but it's not better than the 35. So you can if you do the two fastening method, you can do one screw over the whole roof, but when you go to the pressure zones, the high pressure zones, you got to switch to two screws. All right, going right along. Example 4 at 140 mile an hour gable roof, okay, less than 412 slope. You find that, sure enough, this one has a higher, the high pressure zone has a higher value. So you take that higher value, and if you have a big old tile, you have to factor in the tile ratio. Again, a smaller tile would actually reduce that number, okay? And you look at the low pressure zones, you look at table 3, and flat tile, which is a low profile tile, we use those. The medium profile, we'll use the ones marked in red, and the high profile would use that. Look, as you can see, like certain things may work in one profile tile, but not necessarily the other profile tile. So then we look at the higher zones, and then the same thing. So we've got a combination there. So once again, in this gable roof, one screw will work in the field area, but you'd need to use two screws or some other method that's circled in blue for the high pressure zones. Example 5, okay, in the is the medium sloped range, all right? And again, we have a low pressure zone different than a high pressure zone, okay? We factor in the worst case tile factor of, we get 27.2 for the low pressure. We go to table 3, and those are the fastening methods in a gable roof at 140 miles an hour mid slope that you can use. We look at the corners, the high pressure zones, and those methods are acceptable. So that's that. All right, last example, speeding right along, at the high pressure, high sloped areas on a gable roof, you'll get 21.2 for the low pressure zone and 29.6 for the high pressure zone, okay? And if you factor in a big tile, you get 23.3 for the low pressure zones. And you look over at your table 3, and everything will work in the low pressure zones. When you look at the high pressure zones, okay, the corners, you'll see that for those, pretty much everything works, but not everything. 2 ring shank nails for a high profile tile will not work in the high pressure zones. It will work in the low pressure zones. So that was my quick take on fastening in the high wind zones. Lisa?
I'm here. Thank you, Paul. So I have opened up the mics. You should be able to control your mic to unmute yourself if you have any questions, but I'll just reiterate that the example that Paul went through, there's a recording of that available on our YouTube channel, along with the other wind speeds. They are under a playlist for Florida and the new 6th edition manual, but it'll give you an idea of how the tables work even if you're outside of Florida. Just remember that outside of Florida, you'd refer to the other manual or the TDI, for instance, if you're in Texas. We always say with TRI to refer to the local building official for any specific instructions. And the last thing I'll say is our contact information is up on the screen. You're welcome to take a screenshot of that. You can also find it available on our website. And the easiest way to get to our YouTube channel is to go to the website and click on the icon for YouTube up on the upper right or lower right or left. You'll see the icons for social media. I also will be sending a link with a follow-up email after this recording. So the recording will be available within a couple days on our YouTube channel as well. And I'm not seeing any questions, Paul. So I think
You must have done a great job.
Yes, you obviously covered it very well. So we will close the webinar, and you all have our contact information if there's anything else that you would like to add.